So this is for the Work Energy Standard Take 3, and this is homework problem number 19 in Chapter 6. So we have a plane that's landing on an aircraft carrier. It weighs 220 kilonewtons, and the plane is moving at 67 meters per second. The tail hooks grab a hold of the arresting cables, so that's what the cables are on the back of the plane. And we need to find out how much work is done on the plane by the arresting cables and what the force exerted on the plane by the cables is. Now the book says that both answers will be underestimated since the plane lands with the engines full throttle forward. In the case the tail hook fails to grab hold of the cables, the pilot must be ready for immediate takeoff. Just a disclaimer. And so what we're going to do is first we're going to use the work formula, which is delta E. But we also know that work can be the same as delta K. So delta K is going to be the kinetic energy final minus the kinetic energy initial. And the kinetic energy formula is 1/2 mass times velocity squared. So since the plane is coming to a stop, our kinetic energy is going to be 0. So now we have to figure out what the initial kinetic energy is. So we're going to take 1/2 times the mass, which they gave us in 220 kilonewtons. So if we divide that by gravity, we're going to get kilograms. And we're going to multiply that by the velocity, which is 67 meters per second squared, which gives us a a work force of 50,386.73 joules. So our delta K is going to be negative because it's 0 minus the work force that we just got done. So delta K equals negative 50386.73 joules, which is equal to the work force that the work on the plane by the cables. So next it asks us to find the force. Well, we can manipulate work equals force times delta R cosine theta into force equals delta R cosine theta over the work that we just found. Now, it's going to be delta R. They gave us a distance that it took the plane to stop. So that's going to be our final, which is 84 meters, minus our initial, which is 0, times the cosine of 180, because our forces are going in opposite directions, or the angle is in opposite directions, over negative 50,386.73 joules, which is what we just got our work to be, which is going to come out to the force equals 0.00167 newtons. Now this is a very small number, but we also used joules instead of megajoules.